Hello ladies and gentlemen, this is Mr. Brown here. Today I'm going to be showing you some planetarium software that's kind of similar to what you used on Wednesday, but this one's going to be, it's going to have a lot more information with it and a lot more features that you can use. So we're going to take a look at this one. This program is called Starry Night Pro, and it is available for purchase. It's not a free software that you can download. And this software actually allows you to hook up a telescope to it if you have one, and it can work with the internet. And it can work with the internet to move your telescope for you and locate things in the sky. Now, right now I have my location set to Fort Worth, Texas, and you can see the time is 9 o'clock in the morning. What I'm going to do is switch this to PM, and you can already see now that we've got a very different view. I am facing in the southern direction, and you can see some things here like the moon, and then you've got this glowing cloud in the back that trails all the way across the sky from the southern part to the northern horizon, and that is what you actually call the Milky Way. You're not going to be able to see that here in Saginaw, Texas because of all the light pollution that comes from the DFW area. You would need to go pretty far away from any light pollution out into the country to be able to see what this looks like. And what that is actually a combination of dust and stars. So that faint glow is from billions and billions of stars that are creating that. And this is the spiral of the Milky Way. So just like if you've ever seen a spiral galaxy, this is one of the arms that you're looking at. If you've been outside in any of the recent months and looked up to the southern horizon, you've probably seen the moon with two very bright looking stars. Now they're actually not stars, but it's these two right here. We've got Jupiter and Saturn. So Jupiter's this one right here, and then Saturn is over here. What I'm going to do is, first, we're going to look at the moon, and I'm going to show you some of the features that this program can do. First thing I'm going to do is center onto the moon. This is going to lock my target, and then I can actually zoom in, and we can see a lot of the detail. Now, if you were looking through a telescope here in the city, you're not going to see all this extra stuff in the background. This program is showing all that's out there, but all these galaxies and stars in the background, that's not really what you would see with the telescope. But the detail on the moon here is absolutely accurate, and this is what you would see in a telescope. So it's pretty neat to see all the different craters on here and all the features of the moon. So right now we're in a waxing gibbous phase. That means we're approaching full moon. And you can see right now up at the top, my time is ticking. So as we move, if I'm looking in this direction, the moon is actually appearing to rotate because the Earth's movement. And so since the Earth is rotating, the field of view that we're looking at is actually shifting. So if you had a telescope and you were looking through it, this would happen. The moon would eventually leave the view of your telescope, and you would have to take your telescope and adjust it and reaccount for that. Zoom out now, and we are going to look at Jupiter next. So I'm going to find Jupiter, and then we are going to zoom in on that one. So there's two ways we can do it. We can look over here for it, or we can actually type it up here into the search bar. But Jupiter is going to be this guy right here. So I'm going to center on it, or actually magnify. And the computer program is going to locate it, and then it's going to pull us in where we can actually start to see the moons around Jupiter appear. And Jupiter has the distinct banding on it with its atmosphere. And right now we are missing the Great Red Spot. It's on there. It's just not in view right now. We'd have to wait for Jupiter to turn around so that we can see it. Naked eye, Jupiter looks like a star. It is incredibly bright in the sky. And so if you go out tonight and look towards the south, you'll probably see Jupiter up in the sky. Now, you're not going to be able to see the moons without a telescope. Or a strong pair of binoculars, but Jupiter's in a normal telescope that's pretty powerful. This is probably what Jupiter would look like right here. To get these views like this, these are going to be some of the best telescopes in the world, like your observatories with their giant telescopes. That's how you're going to get views like this. So we're going to look at Saturn next, and instead of searching for it, I'm actually going to type it in, and then the program can pull us to Saturn. click on Saturn, and that should pull us in here now. So what we're going to do is magnify on that. If you've never seen Saturn through a telescope before, it is one of the prettier sights that you'll be able to see. You'll notice as we get closer, you'll start to see the rings appear. And then as we get really close, you can start to see a lot more detail. And one of the things that shocks a lot of people is that when they learn that the rings are not actually solid. They are billions and billions and billions of small pieces of rock and ice and different materials that are floating around. And there are actually gaps within these rings called the Cassini divisions. And that's named after a famous astronomer that discovered those gaps. So through a powerful telescope, you can actually see the big gaps within those. Saturn recently had a probe visited called the Cassini probe that got many, many beautiful pictures and a lot of detail that we were able to see on those photos. So Saturn's always a fun thing to look at. So I want to jump over to Mars, and we're going to take a look at that. And you'll be able to see right now that at 9:26 p.m., Mars is not currently visible from your location. So Mars is not going to rise above the horizon until 10:28 p.m. And it shows here that it will be best visible at 4:47. So what we're going to do is actually jump to that time, and we're going to be able to see Mars. Now, Mars is something, if you go out tonight and look in the eastern sky around 11:30 at night, you're going to start to see it rise above the horizon, and it's going to look like a red star. And so you can actually see Mars with your naked eye without a telescope or binoculars. But as we get closer to Mars, we start to see a lot more detail. We have many different rovers that are on Mars right now exploring the surface, and we're learning a lot more about it. But this is also a pretty cool thing to look at in a telescope. We're going to jump to Uranus, and we're going to see what that looks like. And Uranus is something that you are not going to be able to see without a telescope. Uranus and Neptune are, even with amateur telescopes that you might have, they're still not going to show a lot of detail. It's going to look like a star in your telescope. But to get these kind of views that you're going to see here on the program, you need very powerful telescopes. And a lot of probes that have gone out there have taken pictures that show us this. So to see the kind of detail like this, a telescope in your backyard is not going to give you images like this. It's going to look more like this, a tiny blue dot. It's still pretty neat to know that that's what you're looking at, though. Last thing we're going to do is jump to Neptune and take a look at that one. So right now our program is skewing. It's called SKEW. And what that means when a telescope skews, it means it's trying to locate the object that you're looking for. So you can see that Neptune doesn't look too different than what we just saw with Uranus. It is, it got a little more difference with it. But all these are a lot of fun to look at and try and find in the sky. Now I'm going to zoom back out, and we're going to go all the way back to our original place here. There's a reason that I've pulled these planets, and I want to show you something with that. Now, Jupiter and Saturn are no longer visible because at the time right now, at 4:50 in the morning, they've dropped below the horizon. So what I'm going to do here is back this up, and we're going to go backwards in time to try and see if we can get all of them in the sky. And you can see now our time here is moving backwards. I'm going to go a little faster on that. And so now we're about 3 o'clock in the morning here. We're approaching. And I'm going to go ahead and pause it. And you can see Jupiter is now above the horizon along with Neptune. And then if we bring Saturn, we can see Saturn there. And then Uranus is way over there. And then Mars also. Something special here that we're looking at with all these planets. You got Uranus, Mars, Neptune, Saturn, Jupiter. If you notice the shape that they form, it almost looks like a straight line. And there's a reason for that. And it has to do with something called the ecliptic. Now, if we notice here that line, this is the path that the planets follow. So if we move forward here, you can start to see that the planets are rotating along that. And so the ecliptic is the flat plane that all of our planets orbit around the sun. I'm going to show you a different view here that you're probably familiar with. And it's the solar system in the way that you've seen it before. So we're going to look at the solar system in this view right here. And this is what we mean by a flat plane. So if I rotate my field of view here, this is a plane in geometry. So it's flat. We've got all our different planets orbiting around. So when we're on Earth and we're looking outwards, the reason we see those planets in a line is because they're all following this path around the sun. So if we go back to where we were, we bring up our planets again, make those visible, then what we start to see here is that plane that they're following in. So I'm going to turn on the ecliptic so that we can see it. And you can actually see that line that they're following. So one thing we do notice here about this, I'm going to go ahead and stop time for a second there, is that this line goes up at an angle, and there's a reason for that, and it has to do with the tilt of the Earth. You've probably heard that before, that the Earth is tilted, but if you're not quite sure what that means, think about a globe and how the globe is not straight up and down. It's actually tilted off to at a 23.5-degree angle. I'm going to go ahead and show you a picture here. This is what we mean by the Earth is tilted. If it wasn't tilted, it would be straight up and down, but by being tilted 23.5 degrees, then we can actually see that our equator that we call the celestial equator that runs halfway around the globe is not in the same direction as the ecliptic. So this ecliptic is where all those planets rotate, but our equator is actually just a 23.5 degrees above that. And so that's why that line, when we look at our program here, that's why the the planets are not flat along the horizon. They're actually up at that angle. And that's why we can see them. Now I'm going to go back to this image, and I want to point a couple things out here. The North Celestial Pole. So what this is talking about here is the top of our Earth, the North Pole, points towards an object in space out here. And some of y'all have probably heard of this before. And the nickname is called the North Star. The actual name for it is called Polaris. And we're going to look at that in the program now. And Polaris has this reputation for being this incredibly bright star, and it's actually not super bright. You can still see it without a telescope, even here from Saginaw. But the big difference for it is Polaris is actually about the 50th brightest star in the sky. So it's not this big, bright, glowing object that people think it is. Now, Polaris is in the northern part of the sky. So if you see here, we're facing south. We're going to rotate until we're facing north, and our goal is to try and find it right now. Now, there's a couple ways we can do this. We can type it in up here and have it pull for us, but if we were out in our backyard trying to find it in the sky and you didn't have your computer, there's a few other ways that you can actually locate it. The way you have to do that is you look for shapes in the sky, and that's what you've been learning all week, are your constellations. So you can see a shape over here on the left side that probably looks familiar, and many of you have probably seen this up in the sky, and it is called the Big Dipper. Now, the Big Dipper is not a constellation. It's actually what we call an asterism. So an asterism is a shape that we make sometimes within a constellation, or sometimes it uses different stars from different constellations, but it's a shape that we recognize in the sky. So it is separate from a constellation, but I'm going to go ahead and turn that on for you so you can actually see that. So if I show you the constellations here, the Big Dipper sits in Ursa Major. And this is why you can see that the Big Dipper is not the entire constellation. You've still got many other stars. And so this is the Big Bear. And there are many mythology stories that go with that. But we were talking about how to find Polaris without knowing where it is. And so I'm going to go ahead and show you right here on Ursa Minor, the little bear. Polaris is actually the last star on here at the tip of the handle. And so if you didn't know that, and you didn't know where the other stars are, because they're kind of hard to see, especially here in Saginaw with the light pollution, Polaris is sometimes the only star that you can see in the Little Dipper. But the stars within the Big Dipper are much brighter than these in Ursa Minor. So what we can actually do here is use these two stars down here. This is Dubhe and Merak, and we can point those towards Polaris to find. So back here is Merak, and this is Dubhe, and we can actually take those, and it's about 5 times the length in this direction. We go 1, 2, 3, 4, 5, and Polaris is that bright star that's in that direction. Now there's another constellation over here, Cassiopeia, and if you notice here, it looks like a W or an M, depending on which way you're looking at that. Well, the W is pointed also in the direction of Polaris. So it's a pretty cool way that we can just look at other shapes in the sky and find that. This is what's called star hopping, and astronomers use this to find objects in the sky. What I'm going to do real quick is turn on a label here for the constellations, and we're going to look at that and show you the illustrations with that. So it's sometimes hard to imagine how these shapes in the sky form these elaborate images. And I think we can all agree that, some of these things like Cassiopeia, how does that look like the queen sitting here on the throne? Maybe Draco's a lot easier to see. It does look like a dragon here at the head and the tail. But these shapes, obviously, we don't have lines in the sky. Those lines are imaginary. We connect those ourselves. But this isn't really what astronomers are looking for. They don't care too much about the shapes in the sky. They're actually more worried about the borders for the constellations. And I'm going to show you what that means. I'm going to get rid of our illustrations. And I'm also going to keep the labels on there. But I want to show you what I mean by the borders. If you remember back to the other day, we learned that there are 88 recognized constellations in the sky. And so what you see here is with these constellations, the map or the sky is now turned into a map. And so astronomers use these constellations to locate other things in the sky. If we say that an object is in Ursa Major, it means that it can be anywhere in this section of the sky, this quadrant. So same thing for Draco. If we say that a galaxy that we're looking for is in the constellation of Draco, it means in this direction. Notice that they're not all the same size. Some of them are much bigger than others. Some of them are really small. But this is the way that astronomers are actually using the constellations. A lot of practice to become comfortable enough to know where things are in the sky, but that's all it is practice. And once you look at the sky over and over and over, then you're going to be able to find those objects and know where they are. Now, one thing I want to show you here with Polaris is we said that the north celestial pole points towards Polaris. Now, what this is right here is I want to show you the time frame when things start to move, and I'm going to actually speed it up a little bit here. I want you to keep an eye on what's happening here with the constellations. When we say that the north celestial pole is pointed towards Polaris, that means that the stars are appearing to rotate around that fixed point. Polaris is the star that's closest to the North Pole. It's not exactly on it, but it's so close that your eyes are not able to pick up that difference. But it's just about a degree or so off from that. And actually over time, if you read an article from yesterday, over time we've seen that Earth is, as it's tilted, it's spinning like a top. And so as that top wobbles and go side to side. The Earth is doing that as well. And so the North Celestial Pole isn't always pointed in the same direction as Polaris. But you can see here that it looks like everything is rotating around that star. And I'm going to speed this up even faster so that we can see that. And you can see that this constellation is always going to be above the horizon. So as time moves forward, we can see all the other stars in the sky rotating. And the reason for this is because Earth is spinning. And because Earth is spinning, it's not really that these stars are rotating. Our field of view is. And so it looks like they're spinning around that point. But it's pretty neat to be able to actually see this across several hours. If you were to go outside at night and look up every few hours, you would see a difference in the position. Take a look at one more constellation, one that's not actually visible right now. And this is called Orion. Now, Orion is showing in the sky here, but that's because at this time, it's actually going to be too bright for us to see. But if we change our time to the evening, so I'm going to make it midnight here, or close to midnight, and we're going to jump a few months here. And let's look at December. We're going to change that again, and we're going to go to December. And I said we're going to make it midnight here. We're close to it. And if we look for Orion now, we can actually see that it's visible at night. So the only way you could see Orion right now during the summer is we'd have to turn off the sun, and it would need to be lights out for the day, or you'd have to go to the other side of the world where they can see it. But I'm going to turn off the image here for just a second. Focus just on this constellation. This is what we call the Hunter. And it does kind of look like a person here. This is what we call the Belt. And then down here off the belt is the Sword. You've got this cloud here. This is called the Orion Nebula. And if we zoom in on it and find it right here, if you were to look at this through a telescope, you could actually see this fuzzy cloud. So this is what we call a nebula. It's a giant cloud of gas where stars are created. We'll learn more about nebulas on another day. But this is one of the more famous constellations during the winter time. So this is something that we won't be able to see right now. If you went outside at night, you would not be able to find this in the sky. We'd have to wait a few more months. This is a program that we will be using more this year to look at different things. But I hope you have fun exploring the night sky. Since it is Friday night and you don't have school tomorrow, my task to you is to go outside and look up at night. If you have never done that before, take a chair outside or lay down on the ground, do whatever you need to, and look up. If you don't have a telescope, you can download an app on your phone. There are many different free ones out there. If you pay for them, you get a lot more features, just like this program. The fact that you pay for it gets you more features than some of the free stuff that are out there. The one that I have on my phone is called Skyview, and it's a lot like this program in that it allows you to point it at the sky, and then you move your phone around, and it'll show you things. If you load up your app on your phone, you can actually find Jupiter and Saturn yourself. Saturn is going to look like a faint star, but you'll know it once you see it because it's one of the only things visible in the sky right now. But go outside, look up, see if you can find some constellations. You should be able to see the Big Dipper. Cassiopeia is pretty visible. And then see if you can find Polaris. It's going to be straight north. If you have the app on your phone, you'll be able to find it. But it's going to be straight north and about 30 degrees above the horizon or so. But have fun tonight.